This presentation shows several examples of TCI's HF, Intercept, and single-site direction finding and geolocation system in use. The system has been set to stare at the HF range from 2 to 30 MHz, and the system is detecting, collecting, and performing direction finding measurements on all signals in the HF band. Intercept and direction finding results are shown in several views, including a table or catalog view, a map view, and a spectrogram view. In this first operational example, we show how a single DDC can be set to a particular frequency, bandwidth, and detection mode, and then used to demodulate an AM signal. We then retune the DDC to 15 MHz, while at the same time keeping the spectrogram view on 10 MHz to show that the system is fully capable of collecting on signals other than those currently being displayed on the screen. We then show the ability to directly type in a frequency on the spectrogram screen to show how quickly the view can be changed. We are now both listening to and viewing 15 MHz. Here we can see that the modulation on WWVH on Hawaii is also seen at the same frequency. In this example, we can see that the system is correctly locating the time standard station WWV at Fort Collins, Colorado, and that it is automatically classifying the signal as AM modulation. When the cursor is moved over an intercept on the spectrogram view, the metadata for that intercept is shown. In this example, items such as time, frequency, power level, location, and line of bearing information for the intercept are shown. Using the mouse to hover over lines of bearing on the map display will similarly pop up metadata associated with that intercept. Zooming back out shows that while we were having a close look at WWV and WWVH at 15 MHz, the system continued to intercept, collect, and perform DF measurements on all signals in the HF band. In this next example, we have zeroed in on a CW transmission from a ship in the Pacific. We will now show an example of setting the system up to classify ALE signals, and then filter out all other signals, leaving only the ALE detections on the GUI views. First of all, we will set the system to detect 8-level FSK signals and to add a tag ALE. We will then set the system to record and add a tag ALE1 to all signals between 2 to 30 MHz that are 2 to 4 kHz bandwidth. We then set the filter to show only those signals with tag ALE. You can see that the views are updated instantly to show only those signals in the past 2 hours that are of type ALE. Items in the list view can then be clicked to highlight the associated data in the spectrogram view. All signals have been recorded to a wideband collection array. Here we're showing that a single signal may be extracted from the wideband recording and then sent to an IQ player to be listened to. The IQ player has several mode demodulators, CW being the one most appropriate for listening to ALE. Initially, we show that both audio from the live signal source and the IQ player may be played at the same time, and then we mute the live signal source to concentrate on the IQ player output.